All right, the next standard is similar to the mid-segment theorem. Remember the mid-segment where if we drew a line across a triangle that split the two sides in half, then it was parallel to the other side, parallel to the bottom? That is going to be important for this standard. We got to make sure that these lines are parallel, because if they are, it splits the sides proportionally. Now, if this parallel line happens to be right in the middle of the triangle, it splits them in half, and that's the mid-segment theorem, but it doesn't have to be right in the middle. Let me show you what I'm talking about here. Let's say the right-hand side has a length of 12, and this left-hand side from A to C has a length of 16. So AB is equal to 12, and AC is equal to 16. If it's the mid-segment theorem, then this side is 6, and this side is 6. This one's 8, and this one's 8, because they got split in half. All right, and these segments are going to be proportional. This, from the top to the bottom, is the same proportion as the top to the bottom over here. And when it comes to proportions, it's fractions. So we got to do the fraction thing again. So you'd have to say 6 over 6 is equal to 8 over 8. You cross multiply, you get 48 is equal to 48. If that works, if you get the same exact number, 48 is equal to 48, then you can say, yes, these lines are parallel. So that's going to be half of the problems on this test. They're going to ask you, are these lines parallel? And that's how you check. You cross multiply your four numbers. You set up your proportions. Now you can set up your proportions side to side. You could go, say, left-hand side on the top to left to right-hand side on the top and say 8 over 6 is equal to, and then left-hand side to right-hand side on the bottom, 8 over 6, cross multiply, and you still get 48 is equal to 48. So this is a reoccurring theme. You have a lot of freedom on how you set up your first fraction, but you have to match the second one. The only way you can mess up the first fraction when you're setting up your proportion is to go diagonally. All right, if you go 8 over 6, and you go diagonally like that. This is a bad example because all the numbers are the same. I'll show you in the next one. All right, let me get back to the parallel line does not have to be in the middle. So these sides are still 12 and 16. Let's say that I put my line 3/4 of the way down. So instead of putting it right in the half, I'm 3/4 of the way down. That would make this 9 and this 3. That would make this 12 and this 4. 3/4 of 12 is 9. 3/4 of the way down. 3/4 of 16 is 12. 3/4 of the way down. Does that work? Can we check our proportions to see if they are parallel? Well, I'll do 12 over 4. I'll go top to bottom on the left is equal to top to bottom on the right, 9 over 3. Cross multiply, and I get 36 is equal to 36. So voila, yes, it works. This is what I was trying to say earlier. The only way to set up your proportions incorrectly would be to go diagonally. So let's say you go 12 over 3. That'd be setting up your first fraction diagonally, going from top left to bottom right. That's a no-no. That's how you can mess this up. Then if you try and go diagonally on the other one, you'd have 4 over 9. And you can see when you cross multiply, 12 does not equal 108. Even if you did diagonally 9 over 4, you still have 27 and 48. It still doesn't work. So diagonals don't work. So don't set up your proportions diagonally. Make sure you're setting them up straight across or straight up and down, and then it'll work. So that's half the problems. They'll give you all four numbers, and you just have to check the proportions to see if the lines are parallel. They're going to ask you, are these lines parallel? If your proportions are equal, then yes, they're parallel. If they're not equal, then no, they're not parallel. So like if this was a 5, and you set this up as 12 over 4 is equal to 9 over 5, and you cross multiply, you'd get 60 is equal to 36, and that is a no. No, they are not parallel because these are not equal, they're not proportional. The other type of problem would be the reverse, where they'll say, yes, for sure, these lines are parallel. Since they're parallel, what is the missing dimension? What would be, say, that bottom right-hand corner right there? And then it's still the same thing. Set up your proportions, but now you have to solve for x. So I'll go top to bottom, 12 to 4. I did that last time, so let's change it up. Let's go left to right. So left to right, so that'd be 12 over 9 is equal to left to right 4 over x. So then you cross multiply and you get 12x is equal to 36. And then to solve for x, you divide by 12 and you get x is 3. And that is what x is because it has to add to 12. Now on these problems, they're not going to tell you that the whole thing's 12. That would be too easy. But I just wanted to show you that it does work. So those are your two types of problems. Solve for the missing part by setting up your proportion, or there are no missing parts and you got to show that your proportions are equal to prove that the lines are parallel. That's it. And you've had some practice on this, so again, this test shouldn't be too bad for you.